For this experiment, you'll need several test tubes, a test tube rack, and some sugars. These are monosaccharides, fructose and glucose, disaccharides, maltose and sucrose, and then complex carbohydrates like starch. We also need Benedict's reagents and Selivanov's reagents. You'll need a hot plate. Before starting the lab, we're going to rinse the test tubes with dilute acid and then rinse them with water. It's important in carbohydrate chemistry that the glassware does not contain any base. Heat a large beaker of water on a hot plate. Going to require this in a later step. Once the test tubes have been rinsed, go ahead and label them. It's important to keep track of everything that you do in this lab. This is what 10 milligrams of sugar looks like. We're going to put this amount of solid sample into each of the test tubes and dilute up with about 5 drops or half a milliliter of distilled water. Add about half a milliliter of water to each test tube. This is best done with a squeezy bottle of distilled water. Into each of the labeled test tubes, place 2 milliliters of Benedict's solution. Shake the solutions and then suspend them all in a hot water bath for 2 minutes. Place all the solutions in the hot water bath. Leave them submerged for 2 minutes to let the color change develop. After 2 minutes in the hot water bath, the colors have developed. Record your observations in the data table. After 2 minutes in the hot water bath, these are the color changes observed for Benedict's reagent. Benedict's reagent is a test for reducing sugars. We're going to repeat the process with Selivanov's reagent. Selivanov's reagent detects furfural or 5-membered rings. Give these test tubes a shake and then place them all in the hot water bath for 2 minutes. Place the test tubes in the boiling water all at the same time. Leave them there for 2 minutes. Let the colors develop. After the color has developed, these are the results for the Selivanov's test. We're going to repeat 2 of the tests. This is glucose with Selivanov's reagent and fructose with Benedict's reagent. But this time we're going to add a few drops of base, sodium hydroxide. Sodium hydroxide deprotonates the alpha hydrogen in these sugars, forming an enediol that allows isomerization between glucose and fructose. This should scramble the tests and give us false positives in both occasions. Human saliva contains the enzyme amylase, which is capable of hydrolyzing starch molecules into the individual glucose monomers. We're going to transfer some human saliva into this test tube that contains starch and Benedict's reagent. We're going to give it a shake and put it in the hot water bath.